Okay, and here we go. Hi everyone, this is Ms. Diaz. This is Dr. Alex Ramadan, and she'll be here talking to us about what we went over with solar panels. I know you guys had some questions. I'll let her introduce herself a little bit, what she does. Yeah.
Hi, I'm Dr. Alex Ramadan, and I am from the UK. And I am a physicist working at the University of Oxford on new materials for hopefully better, cheaper solar panels. I feel like that's a good intro, and then I'll tell you more about myself in the questions.
Gotcha. Gotcha. So thank you again for being here with us. Okay, so I'm just going to take some of the questions that some of our students from our third and fourth period had. Basically, one of the questions that I thought this was a pretty funny to ask is I would ask her if she ever felt left out because she doesn't know anything or is confused about what's happening, I guess, in the lab and in your research.
The short answer is yes. But to go into that in more detail, I think whenever you start working in a new lab or you start working in a slightly different area, you obviously know far less than you do if you've been there for a long time. So like at the beginning of working at Oxford, I didn't really know anything. I felt quite left out and, I didn't know what was going on. But I've been here for 4 years now, so I feel like I know what's happening now. But there's still times where I sit in talks and I listen to other people talk about their research and I have no clue what's going on. And particularly even in my own department, like even though I work on physics, there are people who work in astrophysics or different areas. I have no idea. So you get very used to not knowing what's going on. And I just ask loads of questions and everyone loves chatting about their work and themselves. And that's just how I deal with that. I just ask questions.
Cool. Yeah, because I guess once you get to the doctoral like level, you get very focused on like what you have to study. So it becomes very like precise.
Yeah. It's like this. And then I know a lot about a very, very specific technique and very little about everything else.
You're experts.
Yeah.
Second question. So this is more of like, I guess, like the attitude of like how it is to be like a scientist. Is it annoying in some ways, or do you get like, I guess, I guess they said annoying. Do you get over it, or like when your research or your project doesn't go as planned? Like what happens? What are the feelings involved in that?
This happens more often than not, honestly. And it really depends, I think, on like how else things are going in your life. And for instance, if it's like winter and it's cold and you've gone into work and it's raining and then you get there and everything doesn't work, it can be quite disheartening. But if it's sunny, you're like, oh, well, I can just go sit in the park. So I had to learn quite early on to not take it personally when things didn't work. And now I try and give it a day or so and then try and work out what happened. And sometimes you can kind of sense that there's no point putting in more effort. And then other times you can just tell you just need to try again a different day. Because sometimes experiments work one day and then they don't the next. And you have no idea why. And you just have to keep going. I think doing science is all about being persistent. You have to just really want to find out what's happening and then try and forget the fact that it can be really frustrating and not work most of the time.
Yeah, I think that's what, like, we've done a couple of these interviews and it seems like a lot of the, I guess, scientists that we talk to, it seems like it's a lot about just being like staying curious and staying hopeful and just persisting, like you said. Just like everyone thinks that we get these answers so quickly, but that's not how it works,
Yeah.
So thank you for being persistent. They wanted to know, how do you plan to make it cheaper, and what is your plan to make it like, I guess, make the public know about what your discoveries are, so make it more like available.
Okay, so I'll do the cheaper question first. So, I mean, as a scientist, we can't set the price. Like that's down to companies. But what we can do is we can make the way that we make the solar panels a more cost-effective process, and then that gets passed down. Or the real way we can do it is we can make them more efficient. So if you make something better, particularly when it comes to solar power, the better we make them, the more electricity they produce from the light. So the less money you have to spend buying electricity from the grid.
Mhm.
Um, and so essentially that's how we make them cheaper. It's like ideally we make them cheaper to buy, but we also make it so they produce more electricity. So you get that return on your money quicker. But really, cost isn't something I think about a lot. It's just how I try and explain why I work on what I work on to people. Because
Mhm.
otherwise, I think if you can't give people a good reason for why you want to do something, they might not understand why you're interested.
Right. Right. And I think, most of the public understands that we need more renewable sources of energy, and solar panels are probably the most known along with the wind energy. And
Yeah,
a couple of our students have some on their roofs and stuff, so they understand that that's like it's something that could go a long way. So I think
yeah.
that would probably be the best way of getting it out. Especially if you get, like, I don't know what happens in England, but in the United States, you do get like a tax break if you do get solar panels. So different incentives like that. I know some of the kids were like, yeah, my parents were able to get like a rebate, and I was like, sounds good.
Yeah, we have something similar here, but instead you kind of sell the electricity back to
Yep.
the companies and then they pay
Same.
you like 3 times the amount, which is kind of mad. But yeah, we have like similar schemes, and I think they do in Europe as well.
Okay.
Yeah, it's cool.
So I have, is it true? Like, okay, so like I feel like, well, maybe London is, but England is not as sunny, right? Is that like a thing, or is it just like a misconception? So I was like, another.
Uh, it's a tricky one. I would say
Yeah.
it's not a misconception in
Okay.
the sense that it's not always sunny. Like
Hmm.
from October till kind of around about now, it's often quite sad and grey.
Yeah.
But actually, today was super sunny, so I'm feeling, happier about how sunny the UK is today.
Yeah.
Uh, but also, I'm quite south, whereas the further north you get, the worse the situation gets. But with climate change, we have been seeing a lot more sunny days. So maybe that won't be true for much longer. Who knows?
Yeah.
But
So in those cases, I guess when you guys are researching, you're also, I guess, taking that into account. Like, I guess for for solar panels to be used anywhere, or anywhere that like that'll account for, like, I don't know, like the winter time over here. Also, we don't have a lot of sunlight. So would your research also account for things like that when you say efficiency?
Uh, so the thing is, the solar panels always work as long as it's like daytime and there
Okay.
is sunlight. But obviously, they work better if it's like direct sunlight and it's super bright and sunny. So even if you live somewhere like the UK, it's still worth having them. They just won't perhaps give you as much electricity as they would, say, in Nevada.
Right.
Um, so I think a lot of the renewable energy in the UK is provided by wind power, because obviously we're an island and we just have
Yeah.
wind turbines out in the sea. But you definitely see solar panels around here. I guess they're just maybe not as useful.
Gotcha. Okay. Thank you. Is there any other things that you do research on? And yeah, so I'll start with that. Is there anything else that you guys do research on?
Yeah, so we actually do light emitting diodes, so LEDs as
Okay.
well, because one of the cool things about the materials that I work on is you can use them to make solar panels, but also they can emit light. So that's something that some people in our group work on, and I've just started to work on actually. But they don't work that well yet. So um, it's kind of not something I would like to work on things that work really well. This ties back to that question of how do you feel when
Frustration.
things don't work? And
Yeah.
it's like, I'd rather work on something that works. But yeah, sometimes we do research on that as well. Other than that, I don't really do much research outside of my field of like solar panels and the materials that go in them.
Okay.
It's kind of hard once you get to my point to change field too much.
Hmm.
I could probably work on different types of materials for solar panels, but I couldn't really change, onto something completely different. I couldn't go and work in astrophysics, for example. Like, I
Right.
don't know enough.
Right. 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 Because you've gotten so like concentrated in one area. Right.
Exactly.
Okay. Thank you. Um, Let's see. Is there anything else you have to do? So a lot of the kids are very mesmerized by the lab setup and all the things that you have to do to get ready for the lab. So they were like, "Is there anything else that you need to do before you start an experiment?"
Uh,
And mind you, they complain when we ask them to put on their goggles, and that's it. So they're like, "Whoa, miss, stop."
yeah, I think I understand the frustration with the goggles, but it's got to the point where I wear them all the time, so I'm just used to them now. So a lot of the preparing for experiments is kind of thinking about what you're going to do. So I never just go into the lab without having thought through exactly what I want to do. And normally that involves either reading what other people have done or looking over what I measured previously and deciding, okay, that thing was interesting. I want to look more into that. Or sometimes you just get like a flash of inspiration. You're like, I'll try this thing. Maybe it will work. More often than not, that never works. But you know, sometimes you're feeling generous and you want to try it. So that's what I always prepare. The other thing I do, and this isn't related to science, this is just like me personally, I have to have had enough cups of tea or at least a coffee before I go in, and some water as well, because one of the things about our lab is the humidity is controlled, so you get really thirsty really quickly if you're not
Ah,
properly hydrated. And I drink a lot of water, so I have to be like fully hydrated before I go in. And then other than that, I it's just mostly like planning what you're going to do, planning your time. You know, if you have to be finished at a certain time to go and use a piece of equipment, then you just have to make sure you have all of that ready. But otherwise, sometimes I'll choose what music I want to listen to before I get in.
they also like that part too. I think it was the Beyonce that.
Oh, she keeps me going. the, I cannot stress enough how much music like changes a lab-based experience. And whenever I encounter like researchers who don't listen to music, I'm just like, what are you doing with your thoughts?
Yeah.
So it's that, or sometimes I'll listen to a podcast if I'm feeling, you know, like I want to learn. But if I'm in that lab, it's always music.
Now our
So
kids are gonna demand music. And we're like, "Miss, play some music." The scientists at Oxford, they're like, "We can do it." I'm kidding.
sorry.
No, it's all good. I like that you said that you have to prepare before, because whenever we set up for an experiment, I think kids just think, "Oh, give me the instructions and I'll do it." And it's like, no, you have to do some research before, and you have to like start thinking about your setup, and like just your thought process has to be outlined beforehand. So a lot of the kids don't understand that that's a major part of like scientific inquiry, and like just being, you can be curious, but you still need to have a basis for your curiosity. So
Yeah.
thank you for for really making that a point. Um, let's see. So they want to know what made you interested in studying solar energy instead of other renewable sources of energy. Like what made that the focus?
Uh, it's
Or did you think that you were gonna focus in that field when you were, I guess, in
oh.
undergrad or?
I decided in undergrad because I had a lecture course about the chemistry of solar energy, and it had like a little bit of explanation about like all the different types of renewables, and particularly like how they could become a part of the energy solution. And really, I just found it really interesting, and I liked the idea of working on a problem that could potentially benefit humanity. So that's it. It wasn't really anything in particular. It's more just I had this course. I was like, that's interesting. And then I thought, oh, you know, I'll do a PhD in it. And then here we are 8 years later, and I'm still working on it. So
Wow, eight
yeah.
years. So you started about 8 years ago in the PhD program, or is
Oh,
that including your undergrad?
do you know what? It was actually 10 years ago. Oh God.
Oh, good. No, no, be more truthful with the students. They're like, oh, I can be a doctor in like 3, 4 years, and I'm like, no, sweetie, that's not how it works. You gotta look
So
research. It depends. It depends.
yeah. So in the UK, I got my PhD in 4 years, but I
Mhm.
know in the US it can be anything between 3 and 7.
Wow.
And I have lots of friends from the US who, you know, super smart, and that still didn't stop them from taking 7 years. So yeah, doing a PhD is quite an investment of time.
Mm-hmm. Okay. So yeah, I guess that covers that next question. What kind of schooling do you need to become a researcher at a university? And what are the skills? What do you think are the best skills to have? I guess we call them like soft and hard skills. Like, what are, yeah, you understand.
Uh, well, obviously, if you want to do my job, I think you have to be very interested in science
Mm-hmm.
and also be like quite good at it, or at least willing to work very hard. So you don't necessarily have to be like naturally gifted if you're willing to work hard. I think you always have to be wanting to learn, like
Mm-hmm.
naturally be inquisitive. And then in terms of like the more softer skills, I think you have to be good at writing, because there's a lot of writing involved in being a scientist, and that's something you wouldn't necessarily put together. I
Mm-hmm.
think also being good at speaking with other people and communicating your ideas can be a really valuable skill, and not everyone in science has this skill. So when you have it, it really sets you apart. And then my work is very practical. So if you like building things and you like fixing things and then like taking things apart and seeing how they work, that's really helpful. And if you're clumsy, it's not the best. And I'm a bit clumsy. So I have to be super careful when I'm doing things, because I've ruined many an experiment by knocking things over,
Oh,
and not just my own experiments, other people's as well. So,
no.
um, but otherwise, I think that's kind of it. It's mostly just you have to be willing to work hard and what's it called? Discipline. You need discipline, I
Yeah.
think.
Yeah.
And if you have that, then you can just do whatever, I think.
Okay. So what would be like a normal day schedule for someone in like in your field? Yeah.
Uh, it's okay. I'll tell you about a normal day when I'm in the lab, because
Yeah.
I'm not always in the lab. So for me, I'm an early riser. So I like to be in work about 9:30. And then ordinarily I would have a cup of tea, but because of COVID, I have to just go and straight work. So generally I'd spend from 9 to like 12:30 in the lab making my samples. And then I'd take half an hour to an hour for lunch. And then I would spend the next like 4 or 5 hours measuring my samples, whether that's doing some techniques where I shine lasers at them and see what happens, or using microscopes. And then often I'll stop and have a chat with the people I work with, and see what they're doing. And then normally I would sit at my work computer and just have a look over my data. But I'd normally go home by about 5 or 6. But it really depends, because sometimes you find something really exciting and then you want to stay late and kind of make it work. And other times things don't work and then you leave a bit early. But I try not to work too late. That's kind of my personal thing. I like to have, some time off.
Mm-hmm.
So I think that's probably like a standard day.
Okay. Sounds like a good balance. The So I guess the last question, well, this is kind of a broad question. Of course, you think this research is important, but the student wants to know, why do you think this type of research is important? So we will be learning about how humans impact the environment too, kind of go into that. So I think this will be kind of important for them to hear.
Um, oh, well, it's actually twofold. So like there's, on the one hand, because I'm a scientist, I think understanding the world around us, regardless of whether it seems like it would be useful, is a worthwhile thing to do. And I always think the more we understand the world around us, the better we can create solutions to problems and hopefully improve people's lives. So that's my general answer for why we should do all research. But specifically for mine, like, to me, climate change is the biggest problem facing humanity. And unless we change things very soon, there is going to be a lot of suffering. And the suffering is going to disproportionately affect people who don't live in developed countries. And that to me seems really unfair. And so one of the reasons for working on trying to make solar energy cheaper that motivates me is hopefully we can make it so that people in developing countries will have the access to energy that we get, and also we can hopefully, prevent emissions and reduce the impact of climate change. So those are kind of, it's a bit depressing every time I talk about it, remembering why I do this research. But on a daily basis, I don't really think about this. On a daily basis, I'm just motivated by, I want to understand what's happening in my work.
Right.
And I think I'm a bit unusual in the sense that I get annoyed when I don't know what's happening. And so I'm genuinely motivated by like wanting to know because it annoys me not knowing. I'm kind of fueled by annoyance. Most scientists don't really say, but it works for me. So yeah, that's kind of why. Yeah.
It's interesting.
I feel like I shouldn't say that.
No, I mean, everyone has their own motivating factor, and then it's like if that's what works, and that makes sense too. Like you want to find the solution, so that makes sense.
Yeah.
The next question, I had one more question. So the kids wanted to know, like, let's say, like, tomorrow, we're saying like wonderful story. You guys figured out the solution, and you guys completed your project. What would be like the next steps for everyone in your lab? Like, what happens from then on?
Oh. Well, the reason I struggle to answer this question is I don't think we could ever get to that point. Okay. Because I guess the difference is to like your students, what finishing the project might look like is having a real product.
Right.
But to me, what finishing the product would mean, I completely understand everything that's happening in my material, in my solar panel. And actually doing that, you don't need to do that to have a product that you can buy. You just need to understand it well enough. And you can always make things better, right? Like computers are still being improved, even though we have incredible computing power. Like Apple always bring out a new iPhone. So even if we manage to produce an amazing solar panel, we can still make it better. We can make it smaller. We can make it lighter. So I don't think we would ever, finish. But maybe a different type of material that would come along that's even more exciting. And then some of us will go work on that. And that's generally what happens. You just either stay working on one thing or you move on to the next exciting thing. So yeah, hopefully you can see why I found that a difficult one to really answer.
Yeah, no, I mean that makes sense too. Well, like I think also most people have that idea that like science is just like a stagnant like thing, and it's not. It's like you guys are, scientists, anyone that's like involved in scientific thinking is always trying to progress and make better and do better with whatever technology that they have. Yeah, so thank you. My next question is, if you were to summarize how solar panels work in the most basic and elementary way, how would you explain how they work?
Okay.
And I'm not going to say elementary, the most simple, like you can explain it to anyone and they would grasp the solar panel idea.
Okay, I'll do my best. I always try and find a simpler and simpler way to do this, but it's quite tricky because it's a trade-off between being simple and then not lying to people.
Right.
So at its very most basic to me. So what a solar panel is generally you have a material which can absorb light and convert that into electricity. And then you generally have some other materials surrounding it, which can help you to get this electricity out of the material. And they're generally things like metals, which, you can just connect up to a circuit. And with the solar panel, the light shines on it, it absorbs the light, and then a chemical reaction happens in it. And basically, in that reaction, you generate the electricity, and then it has to fight its way out of the material and go off. And sometimes it works really well, and sometimes it doesn't quite work that well. But ultimately, we get a certain amount of electricity out. And hopefully that's the simplest. I don't know, is that too simple?
No, that worked fine. I
Okay.
just think when we explain these things to the students, I'm like, like you said, it's like how can you omit the longer edge of it so that you're not lying to them, but also keeping it so simple enough to understand just the overall workings.
Yeah. Well, the thing is as well, like I think the slightly more complex explanation is more interesting.
Yeah.
But I guess that's subjective, right? Some people might not find science as interesting as I do. So, yeah.
um, I guess that's all the questions we have. Is there anything else that you would like to leave our students with, or anything else you wanted to add?
Um, I don't know. I would be interested to hear what your students. Oh, I suppose they saw the video, so they know what I look like, right?
Yeah.
I'd be interested to know what they think most scientists look like. Whether they think most scientists look like me, or whether they look like older men. Because what I think what's really important to me to share when I speak to students is that sometimes it can seem like science is very white and male, and it really isn't, and we really don't want it to be.
Mhm.
And I know when I was getting into science, I could look around and see that there weren't people that look like me, and that could be quite intimidating. So what I always try and share with people is like, we need people from all different backgrounds, and like cultural backgrounds as well, because science is all about tackling the big problems that face humanity. And if we don't have people that look like everyone,
Right.
how can we solve the problems? So that's really the one thing I'd like to share with your students is like, don't think that all scientists
Fit
don't look
one.
like you.
Yeah,
Like,
fit one description or
yeah,
one
because
square. And it's
that's,
now that you mentioned it, most of the people that I've had these short little interviews with are females or just women in science. So it's always like, I think when they think of scientists, like you said, they kind of like square them into a male, white male box, and it's not necessarily like that. So
no. Yeah. Well, I'm really happy to hear that. I think one of the things I've noticed is like a lot of scientists who do this sort of outreach work do tend to be women.
yeah, and I also see that too. It's more like I want to share. I want to share with the kids. Yeah.
Yeah. Well, I just hope that that will like make them think, irrespective of what they look like, if they want to be a scientist, they shouldn't feel like they can't be. So that's what I would like to share.
Yeah. Well, thank you. I appreciate your time and thank you for coming. And this is international, guys. So she's coming in from whole other side of the pond. Am I saying that
Yeah.
right? A different time zone and everything. So I appreciate this so much. And
Oh,
yeah, I guess that will be all. Unless you have any questions for me, but thank you so much. We appreciate it.
oh,
Um,
you're welcome. And thank you. And I really enjoyed the questions. And hopefully your students will find me interesting.
no, they will. They're like, tell Miss Alex. I'm like, it's not Miss Alex.
Oh, that's nice.
Thank you though.
Thank you.